Welcome to this crash course on programming sensors with the mBot2. In this course, we will build these 5 projects: obstacle avoidance using the ultrasonic sensor, night patrol robot that uses the ambient light sensor. We'll learn to program the loudness sensor and implement the clap to move program. We'll then move on to the tilt to LEDs program that uses the tilt sensor. And finally, we'll voice control our robot using the microphone and AI blocks within mBlock. This is a compilation of 5 previous projects all in one video. So if you are starting out with the mBot2, you can get familiar with programming 5 sensors in less than 1 hour. Let's dive into it. Let's go to the mBlock code editor by going to ide.mblock.cc. First, let's add the mBot2 robot to our devices. Click on Add right here. Select the mBot2 robot and click OK. Now let's add an event so we can control when the program starts running on the robot. We will use button B, the triangular button on the CyberPi, to do this. Let's go to the events block category and use the when button A pressed block, but we'll change this to button B instead. When we press button B, we want the program to start and keep repeating until we press another button to make it stop running. We don't want the robot to start the program and keep running without having a way to stop it. To find a block that can help us achieve this, let's identify the key functionality that we want from my previous statement. Once button B is pressed, we want the program to repeat until we do something. In this case, press another button. In the control block category, there's a block that does exactly this, and it is called repeat until, which repeats the blocks that we define within the repeat until block until some condition is reached. So let's click this and drag it on to our workspace. In this case, we want to repeat the program until a button is pressed, so we can stop the robot driving once we press that button. Since we use button B to control the start of the program, let's use button A to stop the program. The space within the repeat until block with this hexagonal shape is available so we can provide a condition that we want. In general, all conditional blocks have this hexagonal shape in mBlock. If we look into the sensing block category, we see one such conditional block that says button A pressed, and it has the same hexagonal shape, which represents a condition block. Let's drag this and drop it into the repeat until block condition. Alright, the structure of our program is looking great so far. Let's do a quick review before proceeding further. So far, our program says when button B is pressed, we're going to repeat some actions until button A is pressed. Let's move on to defining the actions that we want to repeat within the repeat until block. Now let's think about what we want the robot to do. We want the robot to keep driving straight as long as there are no obstacles very close to it. If the robot detects an obstacle close to it, we want to turn 90 degrees in some direction. For this project, let's define the direction of turning to be left, meaning that when the robot detects an obstacle close to it, we want the robot to turn 90 degrees to the left and otherwise keep driving forward. This will be our objective, and I'll keep it on the screen here until we're done with our program, since it will be a good reference for us as we build the program. Doing something if a condition is met and doing something else if the condition is not met is exactly the definition of the if-then-else block. We can find this block in the control block category right here. Click and drag the block to be within the repeat until block. Next, let's define the condition that we want in the if block. From our objective, we see that we want to turn 90 degrees to the left when the robot detects an obstacle. From the ultrasonic sensor demo tutorial, we know that we can find the distance to obstacles in front of the robot using the ultrasonic sensor. So let's use that to detect if an obstacle is too close to the robot. And in that case, we will make the robot turn left by 90 degrees. We now have to define what too close is with respect to the ultrasonic sensor. The ultrasonic sensor measures distance in centimeters. We will define too close to be 20 centimeters or shorter for this example. You can play with this by increasing or decreasing the value and observing how the robot behaves, but 20 centimeters, which is around 8 inches, is a reasonable value to use. Okay, so now we want to do two things. First, get the distance measurement from the ultrasonic sensor, and second, check if the distance measurement is less than 20 centimeters. We are effectively doing a comparison operation as the condition for this if-then-else block. Let's go to the operators block category to find a less than comparison operator block. This block is the one that we want. It checks if a value that we define is less than another value, again that we define. In our case, we want the first value to be the ultrasonic sensor's distance measurement and the second value to be 20 centimeters. Let's click and drag this block and insert it within the if condition block. Since we want the first value within the less than operator block to be the ultrasonic sensor's distance measurement, let's head to the ultrasonic sensor 2 block category. To do that, scroll down and here it is, the ultrasonic sensor 2 block category. Let's use this block right here to get the distance from the ultrasonic sensor. Drag that onto the first operand block within the less than operator block. Since we want to compare this distance measurement from the ultrasonic sensor to a fixed value of 20 centimeters, we can directly type in the value here by clicking on it and then entering 20. You're making great progress here. We have the structure of the program done now, so let's do a quick review. When button B is pressed, we want to start the program and keep it repeating until button A is pressed, which will stop the program. If the ultrasonic sensor detects an obstacle that is less than 20 centimeters away, we will do something that we are yet to define. Otherwise, we will do something else that we are also yet to define. Great! Now let's instruct our robot to turn left 90 degrees within the if block and instruct it to move forwards otherwise in the else block. For these motion-related commands, head on over to the mBot2 block category. And we see the turn left 90 degrees until done block, which is exactly what we want. Click and drag this within the if block and release. The else part here is to instruct what the robot should do when there is no obstacle close to it. In this case, our objective says that we should continue driving forward. Let's go back to the mBot2 chassis block category, and we see the moves forward at some RPM block. This means that the robot will continue to move forward at the specified speed. Remember, RPM is revolutions per minute, which is a measure of wheel speed. Let's drag this into our else block. From my testing, I've found that 50 RPM is a bit too fast for me, so I'm going to make this 30 RPM. Feel free to adjust the speed as you would like after doing some initial testing with 30 RPM. Wow, that was a lot of work. I'm proud that you've followed along so far. We're almost done, we just have one last thing. Let's think about the case where the robot continues driving forward at 30 RPM like we've defined here, and we want to stop the program. When button A is pressed, we come out of the repeat until block and we end the program. However, since the last command was to move forward at 30 RPM, that is going to make the wheels continue to drive forward even though the program has stopped. What we really want is to stop the wheels before the program ends. To achieve this, we will go back to the mBot2 chassis category and use the stop encoder motor all block. Let's drag this and drop it right after the repeat until block. This will instruct the robot to stop both of its encoder motors, which is just the technical name for the blue motors that drives the wheels of the robot. This way, even if we were moving at 30 RPM and we press the button A, the wheel motors will be instructed to stop driving just before we end the program. So the robot will come to a full stop just after button A is pressed. Awesome work! We now have our complete program and we're ready to test it on the robot. Make sure that the robot is powered on and is connected to your computer with the USB cable. If you're not sure how to do that, I'll add a link in the description to the exact timestamp from one of my previous videos where I show you how to do that. Once your robot is powered on and connected to your computer using the USB cable, click on Upload and then click on Serial, select the USB serial device and click Connect. Great, your robot is now connected. Click on Upload Code. Wait for the upload to complete. And great, your code has now been uploaded. You can now unplug the USB cable from the robot. Great, let's head on over to the robot and see our program in action. For the test setup, I have a few walls here to check that the robot can detect the walls as obstacles, turn left 90 degrees when it gets close to the walls, and then repeat. We have the program on the side, and throughout the test, I will point to the section of the program being executed. This will give you a nice visual understanding of the program. We're going to start our program by pressing button B. We see the robot continue to drive straight until an obstacle is less than 20 centimeters away, and then turn left by 90 degrees, and this process repeats. Let's stop the robot by pressing the square A button. We now see that the wheel motors or the encoder motors have stopped and the program has ended. First, let's add the mBot2 robot to our devices. Click on Add right here, select the mBot2 robot, and click OK. Now let's add an event so we can control when the program starts running on the robot. As in the previous projects, we will use button B, the triangular button on the CyberPi, to do this. Let's go to the Events block category and use the When Button A Pressed block, but we'll change this to button B instead. Once button B is pressed, we want the program to repeat until we do something. In this case, press another button. In the Control block category, there's a block that does exactly this, and it is called Repeat Until. So let's click this and drag it on to our workspace. In this case, we want to repeat the program until a button is pressed, so we can stop the robot driving once we press that button. Since we use button B to control the start of the program, let's use button A to stop the program. If we look into the Sensing block category, we see one such conditional block that says button A pressed. Let's drag this and drop it into the Repeat Until block condition. Now let's think about what we want the robot to do. We want the robot to sense the amount of light in its surroundings. This is also known as ambient light. If the amount of ambient light goes down below a certain level, we want the robot to start driving forward. Otherwise, we want the robot to remain still, that is, both its wheels must be stopped. Additionally, since we want the robot to not keep running after the program has been stopped with button A, We also want to stop the motors before the program ends. This will be our objective, and I'll keep it on the screen here until we are done with our program, since it will be a good reference for us as we build out the program. Doing something if a condition is met and doing something else if the condition is not met is exactly the definition of the if-then-else block. We can find this block in the control block category right here. Click and drag the block to be within the repeat until block. Next, let's define the condition that we want. From our objective, we see that we want to keep driving forward when the robot detects low ambient light. We can help the robot sense the amount of ambient light using a sensor called the ambient light intensity sensor. On our mBot2 robot, this sensor is on the CyberPi and is exposed to the ambient light using one of the small holes on the top right of the joystick on the CyberPi. The small hole on the left is the light sensor, while the small hole on the right is the microphone. Let's use the ambient light intensity sensor to detect if it is dark, and in that case, we can make the robot drive forward. We now have to define what dark is with respect to the ambient light sensor. For this project, we'll define dark to be any light value reported under 2. You can tweak this number. If your room is not very dark when the lights are off, you can increase this number. Let's update our objective to reflect this definition of dark. Okay, so now we want to do 2 things. First, get the amount of ambient light sensed by the sensor. And second, check if the amount of ambient light sensed is less than 2. Now, I want to mention something that is good to build your knowledge, but is not directly related to building this program. If you're in a rush to continue building the program, feel free to skip the next few seconds, but I would recommend listening to it. Unlike the ultrasonic sensor, which provides distance measurements in centimeters, which is a standard measure of distance, note that there are no real units for the ambient light intensity sensed, since it is relative and is not on an absolute scale. This means that you can expect the ambient light sensor to read a higher value when there's more light and a lower value when there's less light, but you cannot expect it to give you the exact amount of ambient light in any standard measure of light, like lux. There's more to what lux exactly is, but to stay on topic, all you need to know for now is that it is a standard unit used to measure ambient light intensity. Now let's get back to building our program. We are going to effectively do a comparison operation as the condition for this if-then-else block. Let's go to the operators block category to find a less than comparison operator block. This block is the one that we want. It checks if a value that we define is less than another value, again that we can define. In our case, we want the first value to be the ambient light intensity measurement from the sensor, and the second value to be the value 2. Let's click and drag this block and insert it within the if block. Since we want the first value within the less than operator block to be the ambient light intensity measurement, let's head to the CyberPi's sensing block category and use this block right here that gives us the ambient light intensity measurement. Click and drag it inside the less than operator's first subblock. Since we want to compare this ambient light measurement to a fixed value of 2, we can directly type that in the second subblock. So we change this 50 to 2. You're doing absolutely great so far. We have the entire structure of the program done now. Let's do a quick review. When button B is pressed, we want to start the program and keep it repeating until button A is pressed. This will stop the program. If the ambient light sensor measurement reads less than 2, we will do something. Otherwise, we will do something else. Perfect. Now let's instruct our robot to drive forward within the if block and instruct it to stop its motors otherwise. Head on over to the mBot2 chassis block category, and we see the moves forward at some RPM block. This means that the robot will continue to move forward at the specified speed. Remember, RPM is revolutions per minute and is a measure of wheel speed. Let's drag this block into our if block. I found that 50 RPM is a bit too fast for me, so I'm going to reduce this down to 25 RPM. The else part here is to instruct what the robot should do when the room is not dark or the ambient light measurement is greater than or equal to 2. In this case, our objective says that the robot should stop driving and stay still. Let's go back to the mBot chassis block category, and we see the stop encoder motor all block. This will help stop the robot's wheels. So let's click and drag this into our else block. Finally, just like in our obstacle avoidance project, when we stop the program by pressing button A, we want to command one last stop to the wheels so that the robot does not continue driving after the program has ended. For this, we will add another stop encoder motor all block from the mBot2 chassis block category at the very end, right after the repeat until block has completed. Awesome work! We now have our complete program and we're ready to test it on the robot. Make sure that the robot is powered on and is connected to your computer with the USB cable. If you're not sure how to do that, I'll add a link in the description to the exact timestamp from one of my previous videos where I show you how to do that. Once your robot is powered on and connected to your computer using the USB cable, click on Upload and then click on Serial. Select the USB serial device and click Connect. Great, your robot is now connected. Click on Upload Code. Wait for the upload to complete. And great, your code has now been uploaded. You can now unplug the USB cable from the robot. Great, let's head on over to the robot and see our program in action. For the setup, I have a light source here to control the ambient light near the robot. You can use your room's light if that is bright enough, but I've found that a brighter source of light, like your phone's flashlight, works best. Make sure that your light source is powered on and facing the robot. Also make sure that any other lights in your room are turned off and there isn't a lot of light coming into the room from a nearby window. We will keep the program on the side, and throughout the test, I will point to the section of the program being executed. This will give you a nice visual understanding of the program. We are going to start our program by pressing button B. We see the robot stay still when the lights are on. As soon as the lights are turned off, the robot starts patrolling, driving forward continuously until the lights are turned back on. We can test this multiple times to make sure that our program works as expected. Let's stop the robot by pressing the square A button. Open mBlock. Let's give our project a name. I'm going to call it Clap to Move and save your program. Let's first add the mBot2 robot by clicking Add, selecting the mBot2 and select OK. As always, we'll start off with the When Button B Pressed event. This will help us start the program when we press button B. Let's print something on the display to indicate that the program is ready and running. I'm just going to say clap to move. Now we want to wait 1 second right after we print this message. This is to prevent any false clap detections from the sound that comes when you press button B. This mainly happens because button B is very close to the microphone, and so the loudness sensor picks up large values when pressing the button. and we don't want the robot to move for this false detection. Next, we'll get a repeat until block from the control category, and this will be our main loop. We want to repeat until button A is pressed so that we can stop the program by pressing button A. And now for the core logic of our program. We want to check if the loudness is greater than some value, and we'll use that logic to detect a clap. So we need an if block, for which we'll go to the control category and use the if-then block. The condition we want to check is loudness greater than some threshold. So we want a greater than block here from the operators category. Use that. The first operand here is going to be loudness, which we can get from the sensing category block. Use the loudness block as the first operand. The second operand is the threshold we want to set. From my testing, I found that a value of 25 works well. Feel free to tweak and adjust this value as needed based on your environment. If you find that claps are not being detected, you might want to lower this value. If you find that there are false claps being detected a lot, you might want to increase this value. Again, this all depends on your environment, so feel free to adjust this as needed. Now that we've detected a clap, we want the robot to move forward, for which we'll use the mBot2 chassis category and use the moves forward block. Remember to use the moves forward at some RPM for a given duration block. I'm going to run this at 25 RPM. Again, feel free to adjust the speed as per your desire. And I'm going to run it for 1 second. Now, when the motors move and the robot is moving forward, you know that there's going to be some sounds from the motor. And since we're using sound to detect the clap as well, this is going to interfere with the loudness detection. So what we want to do is once again wait for 1 second after the robot has moved. You can go to the control category and use the wait 1 second block right after moving. Once the robot moves forward for 1 second, it will wait for 1 second before detecting the next loudness value. If you don't have this wait 1 second, the sound from the wheel motors can cause false clap detections in this if condition block. So adding this waiting for 1 second helps prevent those false clap detections. Finally, we'll clear the display right before we exit the program. And you're done. This is the program for clap detection and to move the robot when it detects the clap. We've also included a couple of wait 1 second blocks to prevent false clap detections. Great, let's connect our robot and upload code to the robot. Wait for the code to be uploaded. And great, it's now time to test it out on the robot and see the program in action. Teachers, there's a plug and play lesson pack for this project with slides and the full program. Grab it on my Gumroad page, linked in the description. Open mBlock and make sure to give your project a name and save it. To start off, we'll use the when button be pressed to trigger the start of the program. The first thing we'll do is add a message on the CyberPi display. We want the message to say something like tilt me. Next, we'll get our repeat until loop, and we'll remain in this loop until we want to end the program. To end the program, we'll give a condition here of button A pressed from the sensing category. Drag that over. Now we want to detect tilts in 4 different directions: tilted left, tilted right, tilted forward, and tilted backward. Since these are conditions, let's bring in 4 if blocks from the control category. Drag that. Once we have one, we can duplicate it, and we'll repeat that process for the remaining if blocks. Now that we have the 4 if blocks, we want to start adding the conditions for each. The first condition is going to be tilted left. All the tilt detection can be done using the motion sensing category, and this tilted forward block Here we can change the direction of tilt detection using the drop-down, and we select tilted left. Next, we can duplicate this block, add it to the next one, and change it to tilted right. And we'll repeat the same for the remaining 2 blocks as well. Just make sure to change the tilt detection direction in each block. We want left, right, forward, and backward. If tilted left, we want the LED pattern to have blue in the leftmost LED, and all the other LEDs should be off. To do that, let's go into the LED category, and we have this display block where we can set the color of each individual LED so we can form a desired pattern. So use the display block here. We can now edit the pattern by clicking on this portion of the display block, which opens up this window. We want the first LED to be blue instead of the default red here. So let's select blue and click on 1. We've now changed the LED color for the first LED to blue. We want to have all the other LEDs off. To do that, we can use the erase tool here and select each of the remaining 4 LEDs. That's it. Now click OK. Great. Now the logic says that when the robot is tilted left, the leftmost LED will be blue and the remaining 4 LEDs would be off. Let's duplicate this block and insert it into the next if condition. If tilted right, we want only the rightmost LED to be blue and all others to be off. So we'll go ahead and edit the pattern. We have blue selected already, so let's select the 5th LED. We want the first LED to be turned off and not blue as is shown here. So we'll use the erase tool again, select the first LED, and we've now turned it off. Click OK. Now let's duplicate this block into the tilted forward condition. For the tilted forward condition, we want the middle 3 LEDs to be green and the leftmost and rightmost LEDs to be off. And we can do that by editing the pattern here. We'll first add the green color to the LEDs 2, 3, and 4, and we'll remove the 5th LED's color. Great, say OK to save this pattern. Once again, we'll duplicate this block, add it to the tilted backward condition. For the backward condition, we want these 3 LEDs to be on, but we want them to be red instead of green. We want the leftmost and the rightmost to be off, which is already done here. So all we need to do is change the 3 greens here to red. Click on the pattern to edit it, select the red color, and change 2, 3, and 4 to red. Say OK to save it. Great, now the core logic of our program is built. Some finishing touches that we'll add. When we end the program by pressing button A, we will clear the screen because we printed tilt me in the beginning of the program, and we'll clear that. We can do that using the display category and using the clear screen block. Finally, we also want to clear our LED patterns and turn all of the LEDs off. To do that, we'll go to the LED block category and use the turn off LED all block. That's it. We have our entire program done. Let's save it. We'll upload the program by connecting the robot first. Make sure the robot's connected using the USB cable. Select connect. Change the mode to upload mode and select upload code. Great, the code is now uploaded. Let's go and test it out on the robot now. Love this project and want to teach it to your students? Check out this lesson pack with detailed slides and full code on my Gumroad page, link in the description. Open mBlock. Let's first give our program a name. I'm going to call it voice control robot. Let's now add the mBot2 robot. Say OK. Let's use button B to start the program. Change button A here to B. As soon as we start the program, we want to make sure that the robot is connected to Wi-Fi. This is because the AI program that we're going to use to recognize speech requires connection to Wi-Fi. To connect to Wi-Fi, go to the AI tab and use the Connect to Wi-Fi block. As you can see here, these blocks are currently disabled. This is because we're in the live mode. We should switch to the upload mode so that these blocks get enabled. Drag the Connect Wi-Fi SSID and password. Make sure to enter your SSID here for your Wi-Fi and your password. Next, we'll add our repeat until loop from the control category. Drag the repeat until block onto your program. We want to repeat these actions until button A is pressed. So go to the sensing category to find the button A pressed block and use that as our condition. Before we perform speech recognition, let's make sure that the connection to Wi-Fi succeeded. We can do that using an if then else block, and the condition inside is we want to check whether the network has connected. To do that, go back to the AI category and use the network connected condition. So in the case that the network was not connected, we'll be in this else block here, and we want to just print a message to the display so the robot can let us know that it's still connecting to Wi-Fi. Let's display a message on the CyberPi using the print and move to new line block, and we will just say waiting to connect to Wi-Fi. Finally, when we end the program, we want to clear the display. So use the clear screen block from the display category. Now that we have the structure of our program, let's implement the core logic within the if network connected block. We want the robot to be able to recognize speech. Let's go to the AI block category to find the recognize speech block. I want the robot to recognize speech in English, so I'm going to change the language here to English. Feel free to select the language that you would like to use for this project. Since our commands are going to be short, like forward, backward, left, and right, we don't really need it to recognize for 3 seconds. I'm just going to reduce that to 2 seconds. Now it will be nice if the robot would let us know before it starts recognizing the speech and after it has finished recognizing speech with some tones. So we can time our voice commands right after the start tone and before the end tone. To add these two tones, let's go to the audio category and we'll use the play until done block. We'll add one before and we'll duplicate this and add it after. We don't need the second recognize, so I'm going to just delete that. For the before audio, I'd like to use the buzzing tone. And for the after recognition audio, I'd like to use the switch tone. From my testing, I found that the buzzing tone was too loud, so I'm going to reduce the volume before playing the buzzing tone. Again, you can do that using the audio category and the set volume block. For the buzzing tone, I'm going to set the volume to just 10%. The switch tone isn't very loud, so I want to reset the volume back to 30%, which is the default, right before I play the switch tone. So let's go back to audio, get the set volume block, insert it before the play switch block, and set the volume to 30%, which is the default. Great, so far we have the entire structure of our program, and in the core logic, we have a tone playing before we recognize speech, and recognizing speech for 2 seconds in the language English, and finally playing another tone after the recognition has completed. What we want next is to do something with the speech recognition result. Specifically, in this project, we want to turn the speech recognition result into a robot motion. In order to do that, we're going to need 4 cases. When the speech recognition result is forward, we want the robot to move forward. Similarly, when it's backward, we want to move backward. When the speech recognition result is left, we want to turn left, and when it is right, we want to turn right. This means that we will have 4 different cases adding those 4 different if then else cases inside here is going to make this program super long. So what we'll do is define a separate block called speech to motion, and we'll add all the 4 cases in that block. To do that, go to My Blocks, select Make a Block, and give your block a name. I'm going to call it Speech to Motion. And this block will take an input text, which will be our speech recognition result. I'll call this Speech Result. Select OK. Now we have a defined block for the speech to motion function. Within our main program here, what we want to do is call the speech to motion function using the speech to motion block, and the input that we'll pass here is the speech recognition result that we can get from the AI block category. Use the speech recognition result block and drag that into our speech to motion block. Alright, most of the structural pieces are in now, and all we need to do now is to define the speech to motion block so it includes all 4 cases that we are interested in. To do that, let's first define the first case of moving forward. We'll use an if then else block, and for the condition, we want to check that the speech result contains the word forward in it. Since we want a contains operation, we'll go to the operators block and use the contains condition here. The first operand is the speech result, which you can drag from here. And the second operand we want to use here is forward. So if the speech result contains the word forward, we want the robot to move forward for 1 second. Before we do that, let's add a display message so we know that the speech recognition result correctly detected the word forward. Go to display, add print, and move to new line. And this message we can just say moving forward. I have a typo here that I'll correct. Now we're ready to make the robot move forward for 1 second. Go to the mBot2 chassis category and use the very first block, moves forward at some RPM for some duration. Drag that right below the print block, and I found that 50 RPM is too fast for me, so I'm going to change this to 30 RPM instead. Now we want to do something similar for the remaining 3 cases as well. So I'm going to duplicate this block, add it inside the else, and change the detection word to backward. We'll also change the message to moving backward instead of forward, and we'll change the action that the robot takes to move backward at the same speed for the same duration. Next, we want to detect if the speech result contained left. So duplicate this block again because we'll use the same structure, bring it inside this else, and we want to check if the speech result contains left. If it does, we will say turning left, and instead of the moves backward block, there is a turn left here, but it will turn left at a specific speed for a specific duration, but it's nicer if we can turn exactly 90 degrees. And there's a different block in the mBot2 chassis category, which is turn left 90 degrees until done. And this block does what we want. So drag this and we can delete the other block. We have one more condition, which is to turn right. So duplicate this block and we'll add that inside the nested else. And the speech result condition is now right. The message will change to turning right. And finally, we want to turn right 90 degrees until done. Now here we see there's an other else condition here. So when will we reach this part of the code? We will reach this part of the code when the speech result does not contain any of the 4 commands that we would expect. For example, if the speech result says diagonal, then the word diagonal does not really contain forward, it does not contain backward, does not contain left, and does not contain right. So then we will fall back into this else case. So any command other than forward, backward, left, or right is considered unsupported by our program. We will communicate this to the user by using a print statement. So drag the print block to the else statement. And here we want to display a message unsupported command followed by the speech result. However, this block only allows us to give one text input. For example, we could say unsupported command here, but we cannot add the speech result. We can do this though by using the join operator in the operators category. So use the join block and bring it to the print block. The first operand to join is going to be unsupported command, and the second operand is going to be the speech result, which we can get from the definition of this block. Great, so now we're going to print one string, which is unsupported command followed by the speech result, and then move to a new line. In this case, we could also play a different audio tone so we know that this command is unsupported. So use the play until done block and feel free to change the tone here. I'm going to set it to the low energy tone. Alright, we have our program fully completed now. One final note here is that because the speech recognition can take some time, and the code will block here before it can continue until the speech recognition is complete. If we want to end the program while this is happening, pressing button A will not have any effect because button A press is registered and detected only when we complete the loop and then get back to the beginning of the loop again during the next iteration. So if we do want to be able to stop the program at any time, what we could do is go to the events category, use the when button A pressed event, and when button A is pressed, we could stop all the scripts that are running. To do that, go to the control category and you have the stop all block. Instead of all, we can say other scripts in Sprite. This means that when button A is pressed, we will stop all the other scripts. In this case, we only have one other script, which is this block here, and then we can clear the screen. So even if we are in the middle of speech recognition, pressing button A will stop the speech recognition in the middle and the program will end after clearing the screen. And that is it. So save your program and we're ready to upload the program to the robot now. Say connect again, select upload code, and wait for your program to be uploaded to the robot. Let's head to the robot now to test it out and see the program in action. Love this project and want to teach it to your students? Check out this lesson pack with detailed slides and full code on my Gumroad page, link in the description.
Forward, backward, left, right, forward, backward, left, right,
Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.